In this video, we'll use our Omen assets and turn them into a deployable ability. Now that we have all the pieces for Omen Smokescreen, it's time to implement them into a playable product. If you want to know how we made each of these assets, be sure to check out our previous Omen video. A link will be in the description below. We'll start the project off by being outside of the Shadow Realm. Disable the skybox and ground, duplicate the boxes, and change one of the materials to the ELPHNT material. This will be used later. Before we can deploy smoke screens, we will need a first-person controller. Since that isn't the focus of the video, I'll be using one from the asset store. Feel free to use one of your own and skip ahead. Otherwise, on the Unity Asset Store, you can get a free first-person controller by downloading the Unity Standard Assets package. Import the package and some errors may pop up, such as GUI text being obsolete. Just replace this with text to get it to compile. Other errors may show up, but just ignore them as we're only interested in the first-person controller. Under prefabs, add the FPS controller to the scene, rename it to Omen, rename the camera to Omen Camera, adjust the position to be over ground, remove the main camera, and add two mesh colliders to ELPHNT B. One will be for the base and the other for the boxes. Now when you enter play, you can move around. With that out of the way, we can get to the smoke screen. We'll start by creating a new smokescreen game object and moving the existing smokescreen and indicator into it. Normally, there should be a center glow and an arrow that tells us the landing position. Make a land position game object and add a sprite renderer. Our arrow will just be a simple triangle, so we'll add this to our project. It's nothing special, it's just a triangle. Change the arrow to sprite and apply the change. In land position, add the sprite to the sprite renderer and change the color to green. Now we'll need to make a script so that the arrow is always facing in the same direction as the camera. To do this, we'll create a script called comp billboard. Here, we'll simply check to see if the camera exists, and if yes, we'll orient the arrow with quaternion.look, passing in the camera's forward. Back in the scene, add the new component to the land position game object. We won't assign the camera here as we're going to reference the camera on instantiation. For the glow, create a center game object. Add a sprite renderer, and under sprite, we'll reference Smoke Sprite 97 as it resembles the center glow the most. We'll attach the billboard script to this object too. Back to our arrow, scale it down to 0.25, make the smokescreen into a prefab, and reset its transform. Create another script called comp Omen and attach this to the Omen game object. In this script, we'll need a reference to our smoke prefab and another reference to store our smoke instance. In update, we'll check to see if the user inputs the key E, and if they do, we'll instantiate a Smokescreen Prefab. Let's remove the Smokescreen game object from the scene, and reference the Smokescreen Prefab. Now when you press E, you should see the Smokescreen Prefab appear somewhere on the map. To actually spawn it in front of us, we'll need a default distance and a reference to the Omen camera. We'll move the smoke's position to the position of the camera, adding the camera's forward vector multiplied by the default distance. Under the component, reference the camera and you'll see that the smokescreen spawns in front of us. Now let's try extending and retracting it. For this, we'll need another camera and a few booleans to keep track of our state. When we go into our smoking state, we'll set smoking to true and switch our cameras. We'll also have the indicator camera's position and rotation match the Omen camera. Back in the scene, we'll create the indicator camera and assign it the same properties as the original camera. And under Omen, we'll reference this new camera. If you enter play mode right now, you'll see it's not quite done. We'll fix this soon, but for now, let's try to exit smoking. In Valorant, one way to exit smoking is to swap guns. In this case, when the player is in the smoking state and uses the scroll wheel, we'll revert everything back to normal and destroy the instantiated smoke object. Now we can unfreeze ourselves, and you can see that the camera snaps to where our character currently is. We want the indicator camera to move with the character, so we'll update the indicator camera's position and rotation using the Omen camera. Now, for extending and retracting, we'll need another float that controls the direction of the camera movement. It'll be set to +1 for left click and -1 for right click. We'll use the direction alongside a smoke speed and smoke range to smoothly move the smoke in and out. The smoke distance will be itself added with the speed multiplied by the direction clamped between the range. We'll then assign the smoke position by taking the Omen camera position, adding that to the camera's forward multiplied by the clamp distance. Lastly, when we move the smoke, we want the camera to follow the smoke too. We'll alter the camera indicator position line to do this. It will be where the smoke is moved back by the smaller of the two, the default smoke distance or the current smoke distance. Back in the scene, we'll assign some of these values within our component. Change them to whatever you feel is appropriate and test. If everything was done correctly, the smoke follows the player and we can move it back and forth within its range. You may have noticed that the indicator doesn't billboard. To fix this, we'll make a public camera property inside comp billboard using mCamera as the backing field. Inside comp Omen, iterate through all the billboards in the children of the instantiated smoke and assign the main camera to the camera property. That should fix it. Now let's handle the arrow. In Valorant, you can see the arrow either points at a viable landing position or defaults to the center of the smoke. In the update function, we'll send out a raycast shooting downward at a limited distance. If the smoke has yet to be deployed and the raycast hits something, we'll change the arrow color to green and position it to the raycast hit position with a little offset. If the raycast doesn't hit anything, we'll change the color to red and move the arrow to the center of the smoke with a little offset. In the prefab, assign the check distance to 15, the land position offset Y to 0.25, the layer mask to everything, and reference the land position arrow. Now you can see the arrow indicates deployable areas. Now let's deploy the smoke. Inside comp Smokescreen, we'll need several game object references such as the purple smoke, the center glow, and the Fresnel indicator. When we deploy the smoke, we'll turn off the indicator, the center glow, and the ground arrow while turning the smokescreen on. Returning to the Omen script, while they're in the smoking state and they press E, we'll call the deploy function and revert the camera from the indicator camera back to the Omen camera. We'll then reference these game objects in our prefab and watch as the smokes deploy. And oops, I forgot to attach a billboard to our smokescreen canvas. And the get component in children function needs to be sent true to include disabled game objects. Now it should look a lot better. So, when Omen deploys his smokescreen, the smoke slowly falls to the indicated position. To do this, I'll separate the animation into 3 parts. The startup, which is the initial expansion, the middle, which is when the smokescreen is stable, and the ending animation, which is when the smoke dissipates. Inside the smokescreen animator, add these new animations with transitions between each of them. The first transition will have an exit time of 1 and a transition duration of 0. However, for the second transition, we want the middle animation to play 3 times before transitioning to the end animation. To do this, set the exit time to 3 with a duration of 0. In the scene, we see that the ending animation repeats. That's because I left loop time on when I made the animation. But that's okay, as we're going to destroy the smokescreen when the animation finishes anyways. With all that set up, we'll be using our SMB event scripts from our character controller video. We explain how we use this in great detail for the character controller, so I'll leave a link to it in the description below. Add the SMB event state machine behavior to the middle and end animations. For the middle animation, set timing to onEnter and name it as middle. For the ending animation, set timing to onEnd and name it as end. Lastly, add the event curator to the Smokescreen Prefab. As a quick explanation, the state machine behavior can invoke events in the curator using its name. Scripts can listen for those events with specific names and respond accordingly. In this case, when the first event middle is invoked, we'll set mFall to true, and the update function will then handle the falling of the smoke until it reaches its landing position. For the event end, we'll simply destroy the smoke game object. While mFall is set to true and a valid surface is detected, we'll calculate the target position and move the smoke towards that location using a fall speed and time.delta time. When the smoke reaches the position, mFall will return to false and it will stop moving. Back in our Smokescreen Prefab, we'll change the fall speed to 1 and the smoke offset to 010. In the curator, reference the smokescreen object and add the onSMB event function that we just created. In play mode, you can see that the smoke drifts down as intended. The blank square can be fixed by giving the sprite renderer sprite an initial value of smoke sprite 0. Now for the screen wipe. We want to change to our smoking state when the screen is fully obscured. We'll first need to enable the screen canvas and set the source image to wipe sprite 0. Inside the wipe animator, add a new state and set that as our default state. For the screen wipe animation, attach the SMB event behavior, and under this component, add an event with the naming as obscured and the timing as onUpdate. Since we're using onUpdate, we need a frame to call this event on. In this case, we'll use 9 as our onUpdate frame, as we can see that frame 9 is at the center of the obscured frames. I'll rename the canvas to screen wipe and add the event curator to the image game object. Then we'll create a script called CompScreenWipe, and from here we'll create a function that crossfades the screen wipe animation without a transition duration. Back in scene, add the new component to the screen wipe and reference the animator in the component. Inside the Omen script, we'll need a reference to the screen wipe, and if the player presses R, which changes the vision in the game, we'll call the wipe function. We'll do the same for whenever Omen enters and exits the smoking state. In scene, add the screen wipe reference, and now you should see the screen obscure when you enter smoking, exit smoking, and when changing to the alternate view. On to the Shadow Realm. Understand that what we're about to do is not the only way to implement this. Another way to do this is to use replacement shaders. We could use regular materials in the normal view and have the camera render with the shadow shader, replacing them when switching to the Shadow Realm. The game probably uses this method, however, the reason we didn't do this is because our method is less technical and our ground has a different mesh shape to correctly generate the smoke waves along the perimeter, so the replacement shader wouldn't have worked well for this specific case. We will create a script called Mesh Swapper, and in this script, we'll create a separate class called GameObjectPair. The idea is that each pair of game objects will have one as a normal version and the other as the alternate Shadow Realm version. We'll create a list of game object pairs, and we're going to create 2 functions. One will be called swap2 that will iterate through the list of pairs and disable the first game object while enabling the second game object. The other will be called swapback, doing the same in the opposite direction. Attach the Mesh Swapper to ascend and pair up the grounds, boxes, and skyboxes with their normal and Shadow Realm variants. Inside the Omen script, reference the Mesh Swapper and create an onSMB event function, and we'll check for the screen wipe's obscured event. If we are smoking and if the alternate vision is true, then we'll call the swap2 function to go into the Shadow Realm. Otherwise, we'll use the swap back to return to normal. We'll also swap back if we've exited the smoking state. Reference the Mesh Swapper in the Omen component, and now when you press E, you should see the Shadow Realm. By pressing R, you can change between the 2 visions. When you deploy, you'll automatically revert back to the normal view. Now for some minor fixes. When you enter the smoke, you can still see the center glow. You should only see this when we're in the alternate view. To fix this, we'll need 2 layer masks, one for the normal vision and one for the alternate vision. When the screen is obscured, we'll set the indicator camera's culling mask to alternate when swapping to and normal when swapping back. We also need to move the center game object of the smoke to a new layer to separate it from everything else. When the smoke screen enters the middle animation, we'll assign the center glows layer using name to layer, passing in the new layer's name that we'll define in the inspector. Create a layer called alternate vision and exclude this layer in the culling mask for both the indicator camera and the Omen camera. In the smoke prefab, set the layer name to alternate vision, and under the Omen component, exclude the alternate vision from the normal layer mask. Now, after you deploy the smoke, you should not see the center glow until you re-enter the alternate view, or the Shadow Realm. And that pretty much sums it all up. You can now obscure the lines of sight of your enemies. It isn't 100% accurate, but hopefully you've learned something, and you're satisfied about how it measures up to the original in Valorant. We hope you enjoyed this video. Omen Smokescreen is just one of many kinds of effects done in Valorant. We're not entirely sure if we're going to continue doing Valorant content, but we'll consider any suggestions in the comments below. Thank you for listening, and we'll see you in the next video.